Okay, so we're going to learn how to calculate the values for this equilibriumly Chatelier principal lab. Okay, so these numbers here are different from what you have in your lab, dry lab data. So please don't copy these. Make sure you use the values that is given in the dry lab data. Okay, so in this case here, number one, we need to find moles of ions or lead, moles of chloride ions, and then total volume in milliliters and liters, and then to get the molarity. Okay, and then at the last part, we do KSV, which is molarity of Pb2 plus times the square of molarity Cl minus. So it should be pretty simple. Now, first of all, we need to find moles of Pb2 plus, and which we know the molarity of this guy is 0.3 right here. Okay, so basically, if I know I use 4 mils, so I'm going to do 4 mils. So I'll label this 1, 2, 3, 4, 5, 6, 7. That way I can show the math here. So step one is 4 mils. Remember, the data that you guys have will be different. 4 mils, I'm gonna go ahead and turn it into liters. So 1 liter has 1,000 mils. And then in that 1,000 mils, 1 liter, we can use the molarity, which is 0.3 of Pb2 plus in 1 liter. Okay, that should give us the moles here. So 1.2 times 10 to the minus 3 moles. So that goes here. Okay, now next step is we need to use the volume, which I put down at 7 mils here for HCl. The reason why I use the molarity of PbNO3 is because 1 mole of this compound gives 1 mole of this ion. So literally the molarity of the ion is the same as this number. Molarity of HCl is the same as molarity of H plus in the solution because it's 1:1:1 ratio. Okay, so number 2, 7 mils, 1 liter, that's 1,000 milliliter, 0.3 moles of H plus in 1 liter. This will give me 2.1 times 10 to the minus 3 moles of H plus. That goes over here. Okay, now total volume. Total volume will be adding all these volumes together. So it's 4 plus 7 plus 9. And it's going to be 3 here. $20. Okay, so that goes over here. 20 mils divided by 1,000 to get the value in liter, 0.200 liters. Oops, I forgot a 0 here. Okay. And then the next thing is we want to go ahead and do molarity, number 5. That would take the moles here over the total volume in liters. So I got 0.060 for this guy. And then let's do the Cl. 2.1 times 10 to the minus 3 moles divided by 0.0200 liters. 105. And technically you only keep 2 suffix, so 1. Okay, then we take number 7, 0.11. Well, yeah, that's the CL. We have to square this and then multiply with the PB2 plus, which is 0.060. 7.3 times 10 to the minus 4. Okay, so all you gotta remember is take this and square it and times with the lead. This is the chloride molarity right here. So this part should be pretty straightforward. Just remember, don't use these numbers here because use the numbers in the dry lab data that's given. The molarity though stays the same. So the moles 0.3 and 0.3 here, that part should stay the same. The only thing that changes is these numbers will change. These numbers will change. Okay. And then read the introduction part to decide if it's endo or exothermic for part A, and also do the same for part B. Now, what's interesting about part B is if they ask for formula, the blue guy literally means the formula is COCl for 2 minus. That's it. And then if it's pink, the pink one is COH2O6 2 plus. Okay, so literally whatever color it is, write down whichever complex ion it is.